overall outer jacket is a protective covering that encloses and protects all the conductors and components of a cable. It is typically made of a durable material such as polyvinyl chloride, also known as PVC, or polyethylene, and it provides protection against moisture, abrasion, and other environmental factors. In the context of National Electrical Code Section 310.15b2, cables with an overall outer jacket are exempt from the requirement to apply adjustment factors when determining their ampacity. This is because the outer jacket provides additional protection against overheating, which reduces the risk of the cable failing due to excessive current. To understand this exception more fully, firstly, we need to define what ampacity is. Ampacity is the current in amps that a conductor can carry continuously under the conditions of use without exceeding its temperature rating. Secondly, consider adjustment factors. These factors are applied when multiple current-carrying conductors are bundled together in a raceway, cable, or earth, because the heat generated by each conductor can raise the temperature of the other conductors. This reduces the ampacity of each conductor, so adjustment factors are used to compensate for this effect. Thirdly, let's discuss Type AC cable. This is armored cable, which consists of insulated conductors surrounded by a flexible metallic sheath. Type MC cable is metal-clad cable, which is similar to Type AC cable, but it may have a smooth or corrugated metallic sheath. Type MC cable can also have an overall outer jacket, which is typically made of PVC or polyethylene. The overall outer jacket provides additional protection against moisture, abrasion, and other environmental factors. When Type AC cable or Type MC cable without an overall outer jacket are installed in a raceway, cable, or earth with other current-carrying conductors, adjustment factors must be applied to the ampacity of the conductors. However, when Type AC cable or Type MC cable with an overall outer jacket are installed in a raceway, cable, or earth with other current-carrying conductors, adjustment factors do not need to be applied to the ampacity of the conductors. This is because the outer jacket provides additional protection against overheating, which reduces the risk of the cable failing due to excessive current. The exception in NEC 310.15b2 applies only to Type AC cable and Type MC cable with an overall outer jacket. It does not apply to other types of cable, such as Type NM cable, which is non-metallic sheath cable. Type NM cable does not have an overall outer jacket, so adjustment factors must be applied to the ampacity of the conductors when it is installed in a raceway, cable, or earth with other current-carrying conductors. To further clarify, let's break down the key components and considerations. The conductors themselves are the wires within the cable that carry the electrical current. Insulation surrounds each conductor to prevent short circuits. The metallic sheath, in the case of Type AC and MC cables, provides mechanical protection and can also serve as a grounding path. The overall outer jacket, as we've established, is the outermost layer of non-metallic protection. The purpose of the outer jacket is multifaceted. It offers resistance to physical damage, such as abrasions and impacts. It protects against moisture, which can degrade the insulation and lead to corrosion. It also provides a barrier against chemical exposure, which is particularly important in industrial environments. The ampacity of a cable is determined by several factors, including the size of the conductors, the type of insulation, and the ambient temperature. The National Electrical Code provides tables that list the ampacity of various types of conductors under different conditions. However, these ampacity values are based on the assumption that the cable is installed in a way that allows it to dissipate heat effectively. When cables are bundled together or installed in enclosed spaces, the heat generated by the conductors can build up, reducing the ampacity of the cable. This is where adjustment factors come into play. Adjustment factors are multipliers that are applied to the ampacity of a cable to account for the effects of bundling and ambient temperature. For example, if a cable is installed in a raceway with all the current-carrying conductors, the ampacity of the cable must be reduced by an adjustment factor. The amount of the adjustment factor depends on the number of current-carrying conductors in the raceway. The exception in NEC 310.15b2 for Type AC and MC cables with an overall outer jacket recognizes that the outer jacket provides additional thermal insulation, which helps to prevent the buildup of heat. As a result, adjustment factors are not required for these types of cables, provided that they meet certain conditions. These conditions typically include limitations on the number of current carrying conductors in the cable and the ambient temperature. The exception is not a blanket exemption. It is important to carefully review the requirements of NEC 310.15 BTU to ensure that the installation meets all of the conditions for the exception. If the installation does not meet the conditions, then adjustment factors must be applied to the ampacity of the conductors. Consider an example installation. Suppose you are installing type MC cable with an overall outer jacket in a conduit with other current carrying conductors. If the installation meets the requirements of NEC 310.15 BTU, then you do not need to apply adjustment factors to the ampacity of the conductors. However, if the installation does not meet the requirements, then you must apply adjustment factors. For instance, if the ambient temperature is too high, or if the number of current carrying conductors in the conduit exceeds the limit specified in the code, then adjustment factors must be applied. Furthermore, it is critical to distinguish between an overall outer jacket and other types of cable coverings. A simple layer of tape or thin coating is not considered an overall outer jacket. The jacket must be a substantial, durable layer of material that provides significant protection against physical damage, moisture, and chemical exposure. The material used for the outer jacket is also important. PVC and polyethylene are commonly used because they are durable, flexible, and resistant to moisture and chemicals. Other materials may be used, but they must meet the requirements of the National Electrical Code. The NEC specifies the types of materials that are permitted for use in electrical installations, and it also specifies the minimum performance requirements for these materials. The exception provided by NEC 310.15 BTU is designed to simplify electrical installations and reduce the cost of materials. By eliminating the need for adjustment factors, the exception allows for the use of smaller conductors in some cases. This can save money on materials and labor. However, it is important to remember that the exception is not a substitute for good engineering practice. It is always important to carefully consider the thermal environment in which a cable is installed and to select conductors that are appropriately sized for the application. Even when the exception applies, it may be necessary to use larger conductors to ensure that the cable can safely carry the load current. The National Electrical Code is a complex and constantly evolving document. It is important to stay up to date on the latest changes to the code and to consult with a qualified electrical engineer or inspector when designing or installing electrical systems. The exception in NEC 310.15 BTU is just one small part of the code, but it is an important part that can affect the safety and reliability of electrical installations. Therefore, understanding the purpose, scope, and limitations of the exception is essential for anyone who works with electrical systems. Remember that proper installation practices are paramount. Even if the cable has an overall outer jacket and meets the exception criteria, poor workmanship can negate the benefits. Always follow the manufacturer's instructions for cable installation and ensure that all connections are made properly. Over-tightening connectors, bending the cable beyond its minimum bending radius, or damaging the outer jacket can compromise the integrity of the installation. Consider also the implications for future modifications or additions to the electrical system. If new circuits are added to the same raceway or cable tray, the overall thermal environment may change. This could invalidate the original assumption that adjustment factors were not required. Therefore, it is important to re-evaluate the ampacity of the conductors whenever changes are made to the electrical system. Regular inspections and maintenance can help to identify potential problems before they become serious. Look for signs of damage to the cable, such as cracks, abrasions, or discoloration. Check for loose connections or signs of overheating. If any problems are found, they should be corrected promptly. The goal is to ensure that the electrical system continues to operate safely and reliably throughout its service life. In summary, the overall outer jacket on Type AC and MC cables provides additional protection against overheating, which can reduce the risk of cable failure. The exception in NEC 310.15b2 allows for the use of smaller conductors in some cases, but it is important to carefully review the requirements of the code and to follow good engineering practices. Proper installation, regular inspections, and maintenance are essential for ensuring the safety and reliability of electrical systems. The specific requirements and interpretations of the National Electrical Code can vary depending on the local jurisdiction. Always consult with local authorities and qualified professionals to ensure compliance with all applicable codes and regulations. They can provide guidance on the correct application of the code and help to ensure that the electrical installation is safe and compliant. They can also provide interpretations of the code that are specific to the local jurisdiction. Continuing education is important for staying up to date on the latest changes to the National Electrical Code and other relevant standards. There are many resources available for electrical professionals who want to improve their knowledge and skills. These resources include training courses, seminars, and online resources. By investing in continuing education, electrical professionals can ensure that they are providing the best possible service to their clients and that they are contributing to the safety and reliability of electrical systems.